So we're going to work through another example. In this particular example, we are going to go through most of our steps, but there is going to be just kind of a slight twist to this one. So we'll go through and talk about this. So in a closely contested school bond election, polling indicates that 50% of the voters are in favor of the bond and 50% are against the bond. Suppose a random sample of 80 voters is selected. Use the following to approximate the probability that the sample proportion will fall within 2 standard errors of our population value of p equals 0.50. So slightly different question. We're asked for the probability that it's going to fall within 2 standard errors. So we're going to have some slightly different steps in here, but a lot of this is going to look familiar. We're going to start by making a list of what we know. So our population is going to be all voters. Our sample size is the 80 randomly selected voters. And our sample proportion, we are told to fall within the standard errors of the population proportion, p equals 0.50. All right, so our first question here. What percentage of the sample would we expect to favor the bond? Well, since our p is 50%, 0.50, we should expect 50% to favor the bond. Does our central limit theorem apply? I'm not going to bother going through our 3 conditions this time. We're going to skip that for the next couple of problems. You will do enough of that in your homework and mini quizzes and things like that. So, and you'll kind of see me do this as we go through problems in the next few sections and chapters as well. We'll do a couple where we make sure we check all the conditions, and then we're going to spend more of our time working through the other parts of the problem instead. So we're going to assume that all of these are met. They all are met if we went through and did the multiplication. We're just not actually going to show it. All right, now we need to find our standard error. Right, so since our central limit conditions are met, we're going to find our standard error. Our p is 0.50. So into our formula, we're going to plug 0.50 times 1 minus 0.50 divided by our sample size, which is 80. This is going to give us 0.056. So there is our standard error. If we can use the central limit theorem, which we can, what is the approximate probability that the sample proportion will fall within 2 standard errors of our population value, p equals 0.50? So what we need to do now is we need to figure out where 2 standard errors below and above our mean are going to lie. So we're going to take our mean, which is 0.50, and we are going to subtract 2 times our standard error. So 2 times 0.056, and that's going to give us 0.388. Then we're going to take our mean, 0.50, plus 2 times our standard error, which was our 0.056, and this is going to give us 0.612. So what we want to know, this is going to be an example of a between problem, so that our probability is between 0.388 less than or equal to p hat, right? So our sample less than or equal to 0.612. Right? So unlike the ones where we were given a percentage that we were looking for in the last couple of problems, we're looking for between 2 standard deviations, so we figure out those values. All right, so then we go to our picture. Our mean is 0.50, and then we're going to use our standard deviation to label everything above and below it. So 0.50, we add 0.056, so we get 0.556. We add it again, we get 0.612. Oops, 0.6 should be 12. 0.668. We subtract, we get 0.444, 0.388, and 0.332. All right, and our problem had the values 0.388 and 0.612. Again, if we look at our picture, this matches up. These are 2 standard deviations away from our mean. So we could have waited until we got to the curve to find those values, which also works, but just to kind of show where those values came from, I erred on the side of caution and put a little bit extra in there. And we're going to shade in, right, all of this in the middle here. All right. Then we're going to go to StatCrunch. And in StatCrunch, we are going to select the between. We are going to put the information in for our mean, 0.50, our standard deviation, which is our standard error of 0.056. Then we are going to go between 0.388 and 0.612, and that is going to give us a value. So the probability that the sample will fall within 2 standard errors is about 95.4%. Now, if we stop and think about this for a minute, this should not be a big surprise, right? Because if we go back and we think about our empirical rule, right? The empirical rule states that we have 95% within 2 standard deviations. So the fact that we got an answer of about 95.4%, so a little more than 95%, should not be a big surprise in this case. So what we have here matches up with what we know about our empirical rule.